Hello everyone. So the next question that we are going to do is copy list with a random pointer, right? So in the question we are given with a linked list where each node is of this particular structure, right? There is a value part which holds a integer value. There is a next pointer that points to the next node, and there is also a random pointer which points to some other random node which is present in the linked list. Also, this random can be null at points. Over here it is in the first node. The random pointer is basically not pointing to any node, so it is null, or it can point to any of the nodes, right? So our job is to create a new list which is having the exact connections as this list over here, right? As the parent list, it should have the same connections. So we need to build the exact clone of whatever the list that was provided to us in the question. Now, what is the problem? You might think that you can iterate through this list over here and then we can just go on making the connections. So if you think in this way, then what will be the problem is, guys, first you make this first node over here which is equivalent to this node, for example. You can fill up the value over here. You can also fill the next. But for example, over here it is null. For simplicity purpose, let us consider that this node was pointing to this third node over here or this second node over here, whatever you take it. Now how do you point this random pointer to this third node if it was pointing to the third node? Because this third node is not yet made. You have just created this. You might make a next and connect to this new node, but how do you make the random pointer if it is pointing to a node that is not yet created? So that is your number one problem. Maybe in the second step you think, okay, that is not possible. Let me just create all the nodes first now. Because earlier I was not able to assign the random with a node because the node was not created. Let me just create all the nodes, right? After that I will start iterating again from the head. And what I'll do is, I'll say that this random node is pointing to null. So I will put null over here. Then I will move to this particular node over here. This is pointing to the first node. So I will point to the first node. But the problem is, this is pointing to a node which is at address 100, So basically if you just copy this over here, then this node will be pointing to this 100 over here. I don't want that. I want this random to point to this first node. So when you are at this location, how would you know that the equivalent node of this random over here is this? You don't have any mechanism to know that because these two nodes are different. So this is why you cannot do it in place by normal iteration. So the brute force approach, which will involve some space in order to know for a particular node what is the random, like the random is this, but what is the equivalent node that we have created for this node over here, that we need to figure out. So the absolute brute force approach will involve taking a hash map. I will be taking a hash map. When I will be creating this node over here, maybe let me just give it address. Suppose the addresses are, for example, I'm giving them as 150, 250, like this. Suppose this is the address that I'm giving to them. Obviously they are different, right? So I'm suppose giving the newly created nodes this address. Suppose they are created at this address, okay. So what I can do is I can maintain a hash map where I maintain like 100, 150. That is the equivalent node of this 100, this node at 100 is this equivalent node. So basically we can make a hash map where I store these pairs. Suppose 100, the equivalent node that is created by us is 150. Then 200, 250. Right, 300 and 350. I can store these reference variables, like whatever the equivalent cloned node of a particular node is, I can store both the addresses, or I can store the entire node. I can make a map of node comma node type which will store both the nodes. So that when I say that this node over here, this random pointer is pointing to this node, I will know that this node's corresponding clone is which node. So basically instead of pointing to this node, I will be pointing to the clone node of this node, right? I hope the things are clear. I'll just write the code and you will be understanding what I am telling, right? You would need this reference of the original node and the cloned node in order to in real time establish all the connections. As simple as that. So let us see what we can do. So the first thing is, suppose if there is a list which is blank, there can be a list with 0 number of nodes, right? So I will handle that case first. So if my head is only null then already I can tell that the list is already reversed. So what I can do is I can return the same head. Okay, this is our edge case. Now I need to make a map which is of type node comma node, right? I'll name this map as hash map hm equals to new hash map, right? I've created this hash map. Now I will iterate through this given linked list over here and try to make as many number of nodes as it is present in the parent linked list. So what I'll do is I'll take a node temp for example and assign it to head first. Then I will iterate until this temp moves to null. Whenever this temp is null, I will stop iterating. Until then what I'll do, I will make a new node. So I will make a new node. For example, let me just directly add that in my hash map. Suppose in my hash map I will add the current node which is temp for example, which is the node in the parent question, and with that I will create a new node and I will assign it the value that the current node is having. So temp.val, right? So this is how we are going to create the nodes and add them in the hash map like I showed you. And then after that I need to increment my temp. I have to keep iterating through this. Temp equals to temp.next, right? So after this particular iteration, same number of nodes will be created and they will be mapped in a hash map. Now in the next step, I need to make all the connections, right? So how can we do that? I will again assign my temp to head. It will start from the beginning again and we will continue until my temp is not equals to null, right? So now I am currently at the first node over here. I need to make connection for its clone node. So let me just quickly take the address of the copied node. So the node copy will be equals to hm.get. So in the hash map, whatever the corresponding node is saved for the current node, that will be its copied node. So I am storing that particular node in this particular variable. After that I need to make the connections. So this copy dot next should be what? The copy of next would be the same as the current of next, but its equivalent cloned node, right? So I will get the equivalent node of the temp.next, right? For temp.next, whatever the corresponding equivalent cloned node is, I will assign my copy.next to that. I hope this is clear. After that, I will need to make the random thing also. So copy.random should also be equals to whatever the equivalent of the temp.random is. So hm.get temp.random, and we need to also iterate the temp. Once I have done this for a particular copy node, I need to iterate the temp and do it for all others. So temp I will be incrementing to temp.next. As simple as that. And at the end of all this, I need to return the head of the newly created cloned list. And I know the address of the head of the new linked list is stored in corresponding of the first node of the actual list in our hash map. So I will return what? Hashmap.get the value of head. So whatever is the corresponding value of head stored in the linked list hash map, I will return that, right? So it is not add, it is put, right? See, it is accepted. So this is beating 100%. So this is a solution. But the problem is it is taking order of n space complexity because we are storing all the nodes in a particular hash map. So we can do that even without this hash map. We can clone the list. So what is the procedure? I've given you a little hint by taking the addresses as this way. So let me just quickly describe you that. So the intuition of solving it without any extra space is that we definitely saw that we need to store this cloned list address and we need to map it along with the original node. And without doing that, there is no other way to find out that which is the corresponding cloned node. So we need to somehow keep a track of what is the original node, and for that particular original node, what is the corresponding cloned node. So how we can do that is, I have already given you an hint when I have taken these addresses. What I can do is, in between two nodes of the original list, I will insert this duplicate nodes, like the cloned nodes over here. So after this first node, it will be this node over here, which is its duplicate. And this node over here, it will again point to the second node of the original list. and after the second original node it will be the duplicate node of the second node, and then this crisscross, this kind of connection we can make. So we are basically saying that for every node the clone node will just be the next node. So if this node over here is pointing to this node, then the clone node which will be the next node of this node will point to whatever the node will be after this, because after this the clone node of this third node will be present. Let me show you what I am saying. I am saying the original nodes, I am drawing them as circle now. Suppose this is 7, right? And this node I will make it point to the newly created clone node. So this is at location 100. After that, this connection will be broken, you can see, because I am creating this connection over here. After that, this node's next will point to this node at 150, that it will point to this node at 13, which is at location 200. Again this will point to this node over here. The next of this node will point to the node 11 with an address of 300 over here. After that, this node will again point to this node over here, and the next will point to the node at location 400. And in this manner we will chain things up. This 450 will in turn point to this node at 500, and the clone of this node will be attached afterwards, and finally this will be storing null is in its next, right? So if I do it in this way, then I can tell that for every node the next node is the cloned node. If I make a connection like this is very easy. So we will be doing this whole thing in 3 steps, guys. This is the end of our first step, where we chain this thing, we create a new node and chain that along with every node, and we say that the next node is the cloned node of a particular node, right? After that, what we should do is we should assign value to all the random pointers of the cloned list, right? For that, what we should do is, first my current will be over here. I will start my iteration from here, and obviously for this current the random is null, so I will set current dot next to null as well, because current dot next is the cloned node. So current dot next, I will assign the next to null if for current dot random is also null. That is one case. And then we will move my current to 2 places, because my current was earlier here, then it will go here, then it will come over here. So basically we will be moving the current to 2 places, so that again our original node of the list is referred to. Now this 13 dot random is 100 over here. So if this 13 dot random is 100, the clone node of 13 should also point to the clone node of 100. So what we should do is, the syntax that should be written is this 200, which is basically nothing but current. The value of current is 200. Dot next is basically referring to the address of 250. Dot random, that is where we should put our value. That is equals to whatever the random of 200 is. That next is the cloned list. So basically what will happen is 200 dot next dot random is basically targeting this location over here. 200 dot next is this 250, because this is pointing to this node over here, and 200 dot next random I want to target. So this point over here, what should I assign to this point over here? I should assign it to whatever the value of 200 dot random is. 200 dot random is 100. So 100 is basically this node over here, and I am assigning it to the next of 100, which is 150. So basically 150 would come over here. So you can see that this 200, this node was pointing to this node over here. Now this will point to this node over here. That is what was required. So this is how we would make the random connections at every step, and then again we will move our current, right? My current will come over here, by 2 places we will move. So this is how we should put all the values of random in second step. This is our second step. And our third step will be, guys, just to make these connections. Break these connections and make these connections. You need to break these alternating connections and make this, and this will be your entire clone list, and also this will again be converted to the main list in one iteration only. These are programmatically very easy. You can just take the addresses and you can just think about it, that how you can generalizely write the code. So these are the 3 steps that you can follow in order to solve this. Again, let me just take it, summarize this. In the first step, we will make alternating nodes. That is the node that was provided to us in this question. They will be followed by a newly created node, which will be considered the clone node of the given node. Then again, this clone node will point to the next node. Again, this next node will have its clone node and it will in turn point to the next consecutive node. That is our first step. Second step is filling the random of all the clone node by this particular operation over here that I have shown. And after that, what you should do is you should make this alternating connections, right? This alternating connections and this clone alternating connection and original alternating connection. This will be done in one step. That is it, guys. Let us quickly show you the code of this particular thing. We will be doing it in 3 iterations, right? So let me just reset this code over here. So first let me just take the normal case. The normal case is basically when there are 0 number of nodes. So basically if my head is equals to null, then whatever my head is, I'll return that, because this is already reversed, I would consider, right? After that, in my pass 1, what I would do is I would insert the clone nodes after the original node. This is what I'm going to do. How can I do this? I'll take a node temp which will be pointing to head, right? After that, while my this temp is not equals to null, what I should do is first I'll make a copy node. So basically node copy equals to new node, and it would have the value of whatever my temp dot val is. With a similar value I will create a different node. Now I need to arrange the connections. So what I'll say is whatever my current is pointing now is the second node, but the new node should point to the second node now. So my copy dot next should be equals to the temp dot next. Whatever my temp dot next is, that will be my copy dot next. Now after I have made the new node connection to the second node, my first node should point to the copy node. So my temp dot next should be equal to what? Copy. Whatever the newly created node is, this is the newly created node, its address I am storing in the current node dot next. After that, I need to increment my current, and I should increment my current twice, so that next time it is pointing to the next node of the original list. Or you can do copy dot next. So basically you can do temp equals to temp dot next dot next. You can do this because already the temp dot next is referring to the copied variable, and dot next will again come to the second one. Or you can directly do copy dot next. You don't already have the address of the newly created node, and in its next I have already given the value of the second node. So you can do temp equals to copy dot next. So after this particular iteration is completed, you can see that for every particular node a copy node will be created, and the links also will be made between them, right? So this is your pass 1. Now in my second pass, I will assign all the random pointers of the newly created nodes, as simple as that. So in my pass 2, what I am saying is pass 2, assign the random pointers of newly created nodes, right? This is what we are supposed to do. How would you do this? Again, bring my temp to head, and then we will be iterating until my temp is not equals to null, right? Over here, what I should do is I would make the connections. So for the connections, I have shown you this thing over here, right? That this 200.next.random should be assigned with 200.random.next. So basically this is our current, where our current is pointing to. The next element's random position should be assigned with whatever the random position of this is to its next, right? That is what is written over here. So what we will do is I would assign the current nodes or the temp nodes next random position with the value of the current nodes next, current nodes random dot next. So this is the line, but there is a case you saw that whenever it is null, whenever my current nodes random is null, then we do not do anything. So we should do this particular thing if temp dot random is not equals to null, because if temp dot random is null, then by default the cloned node is also having null as its random pointer. That is the default value, so we don't need to change it. But if it is not null, then we should assign it. After that, what do? We need to iterate our temp, right? And temp should be, we know that it should be iterated twice. So temp should be iterated twice, so that we again land up on a node which is a part of the original array. This is your pass 2, guys. this is what we do every time. We just iterate, and every time we just assign the random variable of a new node, right? So through this line over here, this line is the main line. Just take a minute and understand this. It's quite easy. So in the third pass, in pass 3, what we should do is restore the cloned and original list. This is what we are going to do. So let us little bit understand how we are going to do this. If this is our current, then I should make this connection. So in order to make this connection over here, what I can do is I can set the 100.next to 100.next. So basically what will happen, 100.next is the next portion of this node over here, that will be assigned with .next, which is pointing to this node over here, and this node's .next is this portion over here. So basically in this portion the address of this node is stored. So I will be making this connection basically, and this connection will be lost. But if this connection is lost, then I will not be getting again this thing. So I should copy the next cloned list's address before making this connection and breaking this connection. So that is something we should do. And after that, after this particular connection is being made and this is broken, I should make this connection and break this connection. How can I make this connection over here? Now the time when this connection was made, then also my this node was pointing to this, which was ultimately pointing over here. So I would assign the next of this to the next dot next, right? Then only I will be getting the address of this node over here, right? So what I am saying is I will again bring my temp to what? Head. After that I will take a new pointer, because see, I have to return a node. I have to return a node which will be the head of the newly created list node. So basically it will be the second node. This second node over here, this is the first node of the newly created list. So I should store this as well, so that I can return this. So I will make a new node answer, and it will always be the second node. So basically it will be head dot next. I will store this, then I will start iterating. I will do until my temp is not equals to null. I will iterate until then. And in every step what I should do before making the original array connection, what I said, I should copy the address of the cloned node. So what I should do is node, did I take a copy? So copy was inside, so I can take another copy. So node copy equals to, what I am saying, it is equals to my temp dot next. After that I can point the current temp dot next to whatever the temp dot next is, right? Or I can say that copy dot next only. I can write copy dot next because temp dot next is copy. Okay, this is, so basically I made the original connection. I made this connection over here, this one, right? Now I should make this connection. So for making this connection over here, what I should do is this copy dot next should be assigned with whatever the value of copy dot next is, right? Because copy was pointing to this node over here, but I need to copy to this node. I need it to point to this node. So it is 2 steps ahead. So I do dot next. But I need to keep, you need to keep one thing in mind, that this last node will be a part of the copied node only, because this last node of the original array must have one of its copy. So in the last copy node, the address of next will be null. So I have to keep this thing in mind, that my copy dot next should never be null. Otherwise I will be operating on null dot next, which will give me a null pointer exception. So this particular thing I will only do if my copy dot next is not equals to null, then only I will do this. And by end of every iteration I should increment my temp. So I should increment my temp to once only this time, because I have already made the new connection. So if I increment once only, it will come to the next node, which is a part of the original array only. So I iterate once only, and after that, after this iteration, I know that the list will be separated from each other, and I need to return this answer node, which is pointing the head node, which is the head node of the newly created list, right? Okay, so there was some internet issue. Let me just show you. I have not changed anything. The code is same. It is accepted, right? And let me submit. So this is beating 100%, right? So this is the optimal approach, and we will do it in 3 passes of the entire linked list, right? but no extra space is involved over here. That is the main factor. That is the optimization that we have performed, as simple as that. Thank you.